Okay, so now let's solve one initial value problem with the help of Laplace transform. Okay, so initial value problem example. So if we have this second order differential equation equal to t, and its initial conditions are here, y0 is 1 and y prime of 0 is also 1. So using the Laplace transform, solve this initial value problem. So for the since we are going to use the Laplace transform, so we will take the Laplace of each term in this equation. So Laplace of y double prime minus Laplace of y is equal to Laplace of t. Okay, Laplace of t. So this will be, now we see that the Laplace of the second derivative is equal to s. Okay, and we can represent the Laplace of y in terms of capital Y. Okay, so it will be s square Laplace of y, which is represented by y, capital Y, minus s times y of 0 and minus y prime of 0. So this is the expansion of Laplace of y double prime. Minus Laplace of y is simply capital Y, and that is equal to, and over here it is equal to Laplace of t. Laplace of t is 1 over s square. We already know, we have already derived the formula. So now in this case, in the left hand side, we will collect the terms of y. So s square minus 1. So s square minus 1, and then minus s, y of 0 was 1, and minus y prime of 0 is also 1. Okay, so that is equal to 1 over s square, and then this is y. Okay, s square minus 1, that is this. So we get an equation y will be equal to so this is s, and then this is 1, so we can take s and 1 on this side, plus 1 over s square, and then it will be divided by s square minus 1. So we get y in terms of s in this case. So this we can simplify as follows. So for example, inside so this will become like this, s square over s square minus 1. If you will simplify it, so it will be s cube plus s square plus 1, if you will simplify it. So yeah, so for this one is y in terms of s. So if we have to take the inverse of that, then we will get the y, because we know that the Laplace inverse of y is y of t. So we need to take the Laplace inverse of this. Okay, so for the Laplace inverse of this, we need to make it into some appropriate format, so that for which we know the Laplace. So in this case, what we can do is, you can do the partial fractions. So s cube plus s square plus 1 over s square minus 1. So we assume that it is equal to a over s square plus b over s minus 1 and plus c over s plus 1. Okay, and then we try to find these constants a, b, and c. So for this, what we can do is, we have to multiply both sides of this equation by this s square into s square minus 1. So we will get s cube plus s square plus 1 is equal to a into s square minus 1 plus b into s square into s plus 1 and plus c into s square into s minus 1. Okay, so assume s is equal to 0. So this left hand side will be 1. So this term will be then minus 1, and then the other terms will vanish because s is equal to 0. So from here we can find s is equal to a is equal to minus 1. We assume s is equal to 1. Okay, so if we assume s is equal to 1, so this will be 3, and this a term will vanish, and then b term will be 1 square is 1 and 1 plus 1 is 2, and then that c term will vanish because 1 minus 1 is 0. So from here we will find b is equal to 3 by 2. B is equal to 3 by 2, and if we assume s is equal to minus 1, so this will be minus 1 plus 1 plus 1, so that will be equal to 1. This term a will vanish, this term b will also vanish because s is equal to minus 1, and this term will be c into 1 minus 1 square is 1, and then minus 1 is minus 2, so c will be equal to minus 1 by 2. So therefore this partial fraction then we can represent as this. Okay, so we have to take the Laplace, so y will then become a over s square. A is minus 1 over s square plus b is what? B is 3 by 2 s minus 1, and a is minus 1 by 2 over s plus 1. So for these terms now we know the Laplace transforms actually. So there may be two ways, both ways are okay. So for example, in one way we will apply the shifting theorem, in another way we will apply the hyperbolic function. So anyway, it's fine. So it is for minus. So from the table, if we will see, 1 over s square, the Laplace inverse is t. Okay, and for 3 by 2, okay, 3 over by 2 is over here, and then it is 1 over s minus 1 term. So for the Laplace of 1 over s was 1. So for s minus 1, the first shifting theorem will apply. So this means that for s minus 1, if the original Laplace was 1, then that will be multiplied by e power at. So where a is equal to minus 1 over here. So e power minus this will be equal to a power. So for example, for the second shifting theorem, for example, if it is a e power at, okay, times a function of t, and then we take a Laplace of this. We take a Laplace of this, okay, some function. So the Laplace of that function is equal to function Laplace of this function f, but with minus a. Okay, so if this is minus 1 over here, so it should be e power plus a, opposite sign, so it should be e power t. Okay, so this will be the one, and similarly for 1 by 2, then it will be the e power minus t. Okay, so now we can represent it like this, so minus t, and then we can represent it like this. So this is 3 by 2 e power t, so this can be represented as e power t plus half of e power t and minus half of e power minus t. So it is minus t plus e power t, and then this value is actually the hyperbolic sign, so sine hyperbolic t. So this is the answer. This is the solution. Okay, remember that from here we have transformed from s to t, so it will not be y, it will be y of t. Okay, small y of t. So this is the solution. So this is the solution of the initial value problem. So this is the same solution we could also get if we can combine these two terms together, 3 by 2 and 1 by 2. And then it will be s square minus 1. So for s square minus 1 in the denominator, we also know that it is the inverse, it is the Laplace of sine hyperbolic. So its inverse Laplace will be the sine hyperbolic t. So in both cases, we can get the same answer. So let's solve another initial value problem. Example 2. So this initial value problem is a homogeneous equation, y double prime plus y prime plus 9y is equal to 0. Y0 is equal to 0.16 and y prime 0 is equal to 0. So taking the Laplace of these, so it will be s square y minus s y of 0 minus y prime of 0 and then plus y prime, so it will be s y minus y of 0 and then for 9y it will be 9y and then the Laplace of 0 is 0. So if we collect the y terms, so y terms will be s square plus 9 and then plus s, so s square plus s plus 9 and since y0 was 0.16, so it will be minus 0.16 s and y prime of 0 was 0, so it will be 0 and then here it is y0, it was 0.16 is equal to 0. So y will then become equal to 0.16 times s plus 1 over s square plus s plus 9. Okay, so this can be further manipulated like this. Since it is in the denominator, it is this term, so we can complete the square of this term. So it will be s plus 1 by 2 square, it will be 1 by 4, 9 by 4 from 9 minus 1 by 4, it will be 35 by 4 and here on the top we can represent it like this, s plus 1 by 2 and plus 1 by 2 and then that is being multiplied by 0.16. So similarly we can write it like this, y is equal to 0.16 into s plus 1 by 2 over s plus 1 by 2 square plus this will be the under root 35 by 2 square. Okay, and the next term will be this will be with this, so it will be 0.16 divided by 2 into this one. Okay, so it will be s plus 1 by 2 square plus under root 35 by 2 square and then here it should be under root 35 by 2 because for the sine omega t Laplace to apply, it should be sine under root 35 by 2, so it means that equally we have to divide it by under root 35 by 2 over here. Okay, so now y of t will be equal to, because it is s plus 1 by 2, so the s shifting theorem will apply, so it will be 0.16 e power minus t by 2 and then for this term it will be the cosine of under root 35 by 2 t. Okay, and similarly for this term it will be it can be simplified, so it will be 0.16 under root 35, so 2 cancels with 2 and then it will be e power minus t by 2 from the s shifting theorem and this is the form of the sine under root 35 by 2 t. Okay, so in this way we will get the solution of the initial value problem.